In today's session, we will be discussing about pure resistance, inductive reactance, and capacitive reactance today. So let us wait for certain moments till some of our viewers join, and thereafter we will discuss in depth what do they mean. Madam, namaste. Happy to see you here. Who else is here? Can introduce yourself, please. Because that will be a very beautiful situation to interact with all of us. Yes, Asuji, glad to see you here again. We enjoy these topics because I have already mentioned in my post. Let us enhance our common sense of science in day to day life. We are not fools. We have to know many things apart from our daily life. So we will start now. And look at the arrangement, whatever I have arranged before all of you through camera. Here is the multimeter, digital, and I have kept it. This mark you could observe, this circular dot over a symbol L. And what does that symbol L represent? I will discuss again. And for measuring L, you have to fix this red terminal. You could see this socket is for measuring 20 ampere of current, and this socket is used for measuring. You can go through CX, LX. CX and LX means capacitive reactance and inductive reactance. So this socket we have to post our red terminal, and this is common for all measurements. You can see this is written COM. So we have to use the black terminal at this particular point every time. And now I will switch it on. You can observe down corner left, it is written mH. This is millihenry as conventionally followed in the history of science. Henry was the scientist who was doing research in this field, and you could see this particular probe or the multimeter indicator is in the range of 200 millihenry. So there also you find mH. Now I shift it to 2H. There also you could see it is written H. So as you shift here, the same measurement will be reflected here. So what is that Henry and millihenry? First we have to know that. I have one point to mention here, here is a bobine format in which we are having coated copper wire wound upon each other, say for example 300 turns, and the ends are here, one and the other end, this end and this end. And what is the inductance value of this particular coil can be measured by this particular meter. So let us first observe that, because that is more important for us today. Let these terminals be here, and I have to find out the end probe for this. These are the two end probes, and what I am to do, I have to bring the reader to 200 millihenry again, and thereafter I connect one at the green point and other at the red point, and let us see the meter, and the meter reads 33.6 millihenry. This is a new information to all of us, even to me, because in my college days nobody taught these things. Now one thing we have to take a note, inside this coil there is an iron piece, and let me remove it in front, so that removing the iron piece I will measure again, and you will again note whether the value of that 33.6 remains the same or got changed. This is drastically reduced to 7.1. So that 33.6 means it was almost 35 and this is almost 7. So 5 times less in value of inductance for this given coil. Maybe whatever length it is there, I do not bother, but the inductance values we count when we start turning it in a loop, in a coil, in a solenoid. So please remember, if it is 7.1, let me switch it to 20 millihenry, and we will see whether this 7.1 is maintained or not, or more accurate result comes out. No value assigned to, maybe it is difficult for the device to measure, so accurate point must be clarified. Yes, this is 7.1 or 7 millihenry. And I confirm again after introducing this iron piece. Inside that space, you will find, let us measure again, same 33.1, say count 33. So this is the value of inductance. And what is that meaning of inductance? It is a measurement of almost how much active this coil is for storing magnetic energy, depends upon this value. That means whenever you are allowing the current to flow through, it will develop some magnetic energy in its volume, and that magnetic energy is indirectly expressed in terms of, that means proportional to inductance. I remove this, the work is over for this particular coil for the time being. I do have another small thin wire coil, it is solenoid rather. Now let us measure again what is the value without iron core. Let me check what does it show. $15.6 because this is thin wire. So more number of turns are available here, and I have already told you the inductance value depends upon mostly the number of turns present on the coil or solenoid. Here is a transformer. I will show you one by one, and these two terminals are the primary terminal and these three terminals are the secondary terminal, not three actually, this and these two. And you know from your experience, or I will inform you today, because this section is connected to AC 220 volt, so this side thin wire is turned around and it is long in length, and let us measure it. What is the value they have mentioned it? Maybe it is more than 200 millihenry, so we have to shift again and check. I place correctly, you have to confirm. You have to look the meter also through camera. Let me see again, up to 20 it has got maximum. This is 7 Henry, that means tremendous value of inductance available here. That means more number of turns are available here, and if you consider these terminals, these are less number in turns, so I have to reduce again. Let us see, we start from 200 millihenry and whether they are accurate or not, let us check. Let us take to 20 millihenry. Let me start from 2 millihenry and we go further. Let's start again from 20 and I will check. No response. It should show, but where is the problem? Even I do not understand. Oh, it is showing. This is 25.8 millihenry. It's okay, no problem. Then I want to show you the effect of this millihenry in terms of coil and iron core present inside. So let me switch it off the meter and I shift this meter from this venue and I start demonstrating here using first this lamp and this transformer primary section I have used. You can see The 3-pin top will be put into the socket from which these two wires coming out, this red is phase and this green is neutral for me, and you could observe this green neutral wire has gone to one end of the primary of the transformer, and then this wire gets connected to the other end through the internal coil and then comes out here, and thereafter comes through this point, then emerges out here and then goes to the lamp, and through the filament it returns through the red wire and then comes to the positive. So, let us analyze from the phase point of view, right. I have already told you the red is phase. So, the phase goes to the lamp directly, filament is there, enters, comes out through the green, this green comes to the coil terminal 1, enters to the coil and then comes out from the coil and then goes back to the neutral of the source. That means, if the system is okay everywhere, this current will be flowing through the lamp and from the lamp through the coil and then to the source. So, let me show you. So, how could I show you? One observation you have to make. This is my source 220 AC control socket switch, and all before you I do, because you know nothing to be hidden. I put the socket here. I will make the switch on before all of you, and then you are requested to see that the current is flowing through the lamp, and the proof is the filament is not red hot, it is red warm. Slight current passes through the filament and then through the coil and then to the source. My point is that if there is a wire of copper wire, maybe thin, I do not bother, wound upon here on iron core, then what happens to the current when it is flowing through this device? It consumes maximum energy, because I have already told you this develops magnetic energy, and because of magnetic energy the lamp filament does not get suitable values, that means suitable voltage or suitable current or both effectively and to glow perfect. So, this is just a proof that the current is flowing in the system. And now I keep it here and I show you something very interesting. Suppose you know by this time the current is entering here, coming out here. Then one thing we will do, if this is a high resistive path, that means a reactive path for the alternating current to flow, what I am doing before all of you, I will touch these two terminals with this piece of short piece wire, so that we will allow the current not to flow through this, rather the current will be finding a easy path here, so that the current will not flow inside that, but through the wire piece outside, and you will be happy to note this lamp, particularly the same lamp which is glowing almost faint, now started glowing full as required, because this is just a 15-watt lamp. So, this confirms that current always finds the easiest path to flow. It will not prefer this difficult path until unless there is a easy path. If there is a easy path, it will choose the easy path, not the difficult path. Remember, this is the duty of the nature. The character of nature is to always follow the minimum energy path. That means the shortest energy path. So I put it again there, and now I will show you another beauty. This is called the inductive reactance, and it is offered to alternating current. Remember, if you are using DC current, that I will do in another program, if you are using DC current here, then this coil would not provide that much of reactance to the current, rather it will be allowing the current to flow, and this will glow better than this alternating current. Now we do have a friend of ours which is called a capacitor. What is a capacitor? We almost all know that two metallic foils separated by a fine layer of insulation are rolled and packed into this container, and these two terminals coming out for connection outside. So let me switch it on again, the power, so that you can see better with the light what I am doing. Observe please. These two wires are taken out from the metallic foils for connection to the external circuit. And the value of this capacitor is 30 microfarad as written. You could read, and voltage is 440. You can read AC. This is also not suitable, not designed for operation on DC, not for battery voltages. So what I am doing, as I have said, everything is there in your front, current is flowing, and I keep this capacitor before all of you, holding these two terminals with care and touching these two terminals of inductor, placing properly. You could see the capacitor is a friend of alternating current, and inductor rather is an enemy to alternating current. It strongly opposes the flow of alternating current. Now the combination of capacitor and a inductor creates beauty in the signs of alternating current, and the lamp started glowing full again. The moment I remove, the same problem, I discharge it. Otherwise, if you touch, you get shock. So what we could observe initial round, inductance, how do they originate, their measurements, their values, their units, different types of coils we have made by me, transformers and their inductance, primary, secondary, and I showed you primary is having high inductance and secondary is low inductance. One thing I want to show you, if you are studying the current science and now the secondary is open, now you observe, if I close the secondary loop by this surface wire, maybe you will observe something new. the glow of the lamp increases. This is another beauty we could observe. If you touch the secondary, that means if you make the secondary circuit close, the primary coil is not angry, it allows more current to the lamp because it is happy now that energy balanced. This is also one beautiful observation we made today. I make it off, and now we are ready to proceed to low voltage operation. This was using 220 SE. So I put them aside altogether. Their job is over, their drama is over. Now this comes into view. This is the rather heavy one. We will again measure what is the inductance of this primary coil and measurement of inductance of the secondary coils. This is again important for all of us because you know material to material they differ. So what we do, we put them side by side so that we can see everything together in our view. I hope we are okay. Now before we power everything, let us test, make the device on. Unit is millihenry. I zoom little bit and I touch the primary terminals and I show you what is the value it offers, whether it is Henry or millihenry. We have to shift to 2 Henry, whether it is more than that, I will shift gradually. This is 1.527, and in the previous case it was 7 Henry, remember, because there was a thin wire and because this is a heavy transformer, so it has got little thicker wire in the primary and more thicker wire in the secondary. I will again check the secondary now, 200 range. These two terminals we check first. In the previous case it was 25 and in the present case this maximum is 22.7, where I have already told you this is thicker wire and that wire thinner wire. So, number of turns might be more in the previous case than this case, is 22.7. What about these two? Gradually reducing, you just see, so also the voltage factors. This is 24, that means 12, 12. This is 0, 12. This is 13. This one 6.1, 1.4. So again we measure. This is in millihenry, please remember, not in Henry because they are little thick wire. These two terminals, number of turns least I think, so 1.3, again more terminals, more turns, 6, furthermore 13.8, furthermore 22.7. So what I will be showing now after measurement, we have to do experimentation And how do we experiment? Keeping it here, I will provide 220-volt supply to the input, this section. This section will be again alternating current, and these two terminals I am using for the time being. So, this is 12 volt. I am having a lamp 12 volt, little powerful lamp compared to this particular lamp. So, we will use two different lamps for our experiment purpose, and the same 220-volt source will be used. I do not show you repeatedly. What I am showing you, first we switch it on and provide the power to the 12-volt source. Let me connect. This connection is by a connector. Maybe this end is a factor. It is a little thicker, and this particular portion I will twist, again twist, put it here, tight. This one, maybe because of this soldering, this terminal is playing with me, not going inside. It is not a problem for me for the time being. I want to show you this is glowing, very high glow, but now you observe this high glow will be changed the moment you allow the current to pass through this inductor to the lamp, as we did in the last time. Through our transformer we provided the power. So, what I am doing now, I will connect this terminal, green terminal, to this connector. So, current now will be passing through the inductor. Thereafter, the inductor second point we have to connect. Connect to whom? Connect to another connector I do have here. Is connected, please observe. And again, this lamp N terminal will be connected to this point. So, let me use it. It is disturbing me again and again. So, what I have to do, ultimately I have to cut it. Let me see connected or not connected, and I hold it to show you, and you just see everything is okay, but the lamp is just glowing. You can see the filament is simple red worm like that. I switch it off the light. and you will see again I keep it in the dark, and you can see much better that this lamp allows the current to flow through, but the lamp does not get suitable energy because the current is mostly used on this particular segment or component in the form of magnetic energy because of its inductance. So, 1 minute, please wait. I am back. Why did I go? You might understand. I went to bring this because this is getting disturbed repeatedly. So, what I have to do, I have to cut it, the head one, and thereafter my portion is left behind. And I introduce again so that you could check this is not disturbing further. Now, we repeat this experiment again, switch it on, filament is getting warm, the flow of current is confirmed. This is called closed circuit. Now, before you only, I keep it here to show you that whenever we remove this iron piece from this, the glow of the lamp is increased further, right? That means more energy comes to the lamp compared to the previous case, because this iron piece helps the inductor to magnetize better. So, to consume more energy it was used, and this is a proof now that for inductors soft iron core is very essential in electrical industry. If you want to utilize magnetic energy to maximum level. Now, before you again I introduce this piece. When this goes in, the current is further reduced and drastically low, and I want to replace this lamp with the other lamp that we had, and we see what is the new change, new observation for all of us. This lamp I want to change it. So, same thing, replacement process to be followed. Where is locked is not coming out, then this piece will be connected directly through this. So, what is the idea? Let us discuss first. Idea is like this: the whole system is connected. You could see the lamp is with me, and let me switch it on. This time we find, because this lamp is less energetic, so whatever current comes to the lamp, it is little more than the previous case, and this lamp glows better than the previous case. But we have to again observe whether this glow, whatever is there, is actually increasing further with the removal of the iron core or not. You have to carefully observe. The variation is slight. slight only. That means here I want to point out one important thing. The resistance of this particular filament counts here to a large extent for the calculation of three combinations. And now let me summarize what are the three components we are connecting in alternating current circuits. Pure resistance, this one. This is common for both AC and DC. And then inductance, this is responsible for change of behavior in AC current, not in DC current. And then the last guest with me is the capacitor. So in all electronic circuits, our engineers they use extensively these three components to design the circuits: resistor, inductor and capacitor of different values for different mechanisms, for different operations in the knowledge of electronics engineering. So you see, from electrical engineering, people migrated to electronics engineering after studying this branch of science. Is called the LCR. That means L represents inductor, C represents capacitor, and R means resistor. So we will now measure the value of this resistor and the previous lamp resistor. So please be ready. I bring my multimeter again and let it be here, and I have to change the terminal to ohm here. This is called the pure resistance, and this particular red probe should be opened from this point to be again reconnected this point, which is called the ohm, again another ohm. So let me connect here, and I take this selector to minimum value available here is 200 ohm. The unit is ohm, please remember. And what I want to show you now, I want to remove this heavy transformer from this particular point. Let them go there. Meter should be here. Meter should be zoomed. And I have this lamp with me. The points to be connected by the meter probe, one this particular point, remember this terminal, and the other one is the body. This metallic body is one terminal. So what I want to show you, that if I put the red here on the body and the black here on this tip, the reading shows, make it on, the ohm symbol comes here. This is, I think, I do not know exactly, let us see, 2 kilo ohm I increased. This is 0.004 in the range of 2 kilo ohm, or if you tight it, then it is getting little higher. Let me take it to 20 kilo ohm. We will check one by one, step by step. I reduce 200, Yes, this is right now. This is 4.1 ohm just, remember. And in the other case, in the previous lamp, which is here, you will observe these are the 2 points available for me to measure because they are already soldered. You could check these are the 2 points available. So let me use before all of you. I put one here and one green on this probe, and the reading says only 0. See, it is 0.7. It is more than that. So the thing is that if you want to know what is the value of the resistance for this particular 220-volt lamp, because this has got also certain filaments and the terminals are 1 and 2, these two. So let me connect again to show you what is the resistance of this particular lamp. Let me hold it properly, then only I can measure it perfectly. Resistance value is increasing, I think. In the range of kilo ohm, this is 0.503 kilo ohm. That means it is very high resistance. So remember, less is the watt of the lamp, most is the resistance of the lamp. That means most resistance means least current will flow and least energy in the form of light will be liberated, and that is why these are all used for night lamp purposes previously, but nowadays they have been replaced by LED lamps. Remember, previously we are using this lamp as night lamps, and these lamps were 15-watt lamps. Throughout the night they will be consuming 15-watt rate, but the present LED night lamps are 0.5 watt or 1 watt maximum. So this is the idea about plain value of resistance, and now we will be switching to measure the value of capacitors. This is 30 microfarad, 440 volt AC, and I have to select here the proper selector. Farad, microfarad is here in this section, remember, F and all those readings. So I have to now shift my main terminal from this particular circuit. Remember, from this particular circuit where you can measure only volt, ohm and hertz, to this particular circuit where you have observed earlier is written Cx and Lx, that means capacitive reactance and inductive reactance. So I put it here, right. So these are the two terminals placed properly in the digital multimeter, and the selector should be now changed to 200 microfarad. I have selected because my reading on the capacitor is already known to you. It is mentioned 30 microfarad. So when I use this before all of you, you will be happy to observe I have connected these two probes, and the reading says 33 microfarad, even though company has mentioned 30 microfarad. So whenever designing components like this, slight variation may be there which are allowed. But in electronics industry, this variation is not allowed. In electrical industry, this variation is allowed. So 33.5 microfarad. is capacitance of this particular capacitor. So I hope I have covered a big journey for all my viewers. I thank you all my viewers who are available here because they are happy with the program to learn many new things. I have already told you, let us increase our common sense of science in day to day life. Even though we are not a student of science, we may see, we may learn, and we may enhance for the sake of our children. So I started my journey from inductance, inductor, its values, measurements. Thereafter, I selected inductors like solenoids and transformer coils, inductors with core, without core, then testing of their values and verification of what is their role in the alternating current circuit. Thereafter, we switched over to measurement of plane resistance, which is measured in ohm. And finally, I concluded my demonstration with a capacitor whose value is microfarad range 33 and use of digital multimeter for all these purposes. Remember, in normal multimeter, this facility, whatever we do have here, is not there. So there are basically varieties of multimeters for purposes of different purposes of use. So you have to, whenever you want to buy, you have to focus on what to measure and how to procure. I switch it off. This is a very good digital multimeter for me because I do a lot of work with this. And then before we leave, let us have a quiz. And this quiz is a family quiz. All who are present should answer. Whatever I have mentioned, I will be summarizing from that only. Question number 1. The unit of capacitor, whatever I have used today, is expressed in terms of, I give you option and you have to choose the right option. Option 1, microfarad. Option 2, farad. So out of these two units, you have to choose the right answer. In what unit my capacitor was valued? So please answer number 1 or 2 in your chat box. If you do not answer, then I have to answer ultimately for all of you. The right answer is microfarad, not farad, because farad is a very high value which we never use. Maybe scientists are using for all different purposes in the range of farad. And this unit has been named in the name of Michael Farad. Now the second question is like this. When measuring the value of the inductors, we have used two different units. We have used millihenry, where it was written mH, and we have used another unit. So please tell me, what is that? What is the higher version of millihenry? As available in the meter, a meter is in your front, and you can check the meter and answer me. What is the higher version of millihenry? It is beyond 200 millihenry. It has been mentioned, so you have to just see and write. And my digital multimeter says this is Henry, and it starts from 2 value and then going to 20 value. So 20 Henry means a big value. And you have already observed the small transformer primary coil was having value 7 Henry, and the bigger transformer was having value 1.1 Henry. So we are using using those values. And now the final question for all of you: this resistance is used for controlling the current, for liberation of energy, and please tell me what is the unit in which the plane resistance is expressed. You just go through the multimeter I show you again and tell me wherever there is an omega sign, that one is the right unit for expressing the resistance of the resistors, and they are having different values right from 200 ohm, starting from 200 ohm and then through 2 kilo ohm, then 20 kilo ohm, then 200 kilo ohm, then 2 mega ohm, then 20 mega ohm, and then finally 2000 mega ohm. This range is having, it is a big range, and the unit is ohm, the sign of omega. So with this हमें इजाज़त चाहिए to conclude this program. Again we will meet some other day. Tomorrow I will not be available. I will publish again for the new topic. Until then, have a nice time, have a nice day, nice lunch, and enjoy your time with freshness of knowledge. Thank you all.